as we talk about function operations, what we want to remember, or what we're going to be learning, is combined functions. Okay, real quick, f of x, that is pronounced, this is f of x, otherwise known as the output. But it's how you abbreviate function. So when you see f parentheses, x parentheses, that is just function. So what we're going to learn here is we're going to combine functions using arithmetic operations, addition, subtraction, multiplication, and division, expressing results both algebraically and graphically, evaluate sums, difference, products, and quotients of functions. Okay, so combining, okay, when we combine functions, before we go into that, let's just go back to this, f of x. This is also really, we can think of f of x as the same thing as our y value. So when I have a graph, I may have f of x and x, which means whatever x value I put into this function is my y value, my output. So there, my x value also represents the domain of a function, and my y value, or my f of x value, represents the range. And we know, hopefully we remember, that the domain is what I put into a function, and the range, or the f of x, is what I get output of my function. So if I have a point here, 3, 1, the x value is 3, and the y value is 1. So I could write that over here in that notation as f of 3 equals 1. Because when I put 3 into my function, it gives me an output of 1. So f of 3, x is 3, when x is 3, y equals 1. And that's just my function notation, trying to remember some of those things. And again, my domain is my x, my range is my y, or my f of x. Right here it says we're going to evaluate. So let's see here. So polynomial operations, when it says that we're going to combine these, well, we're going to learn here, and it talks about, we'll just use f of x plus g of x. And that could be addition or subtraction, but I'm going to take this function f of x and I'm going to add it to g of x. Well, okay, if I say that f of x is equal to x, and then g of x is equal to x plus 3, well, I'm just going to do some substitution. Well, f of x, we just said, is equal to, f of x is equal to x. So instead of f of x, I'm going to substitute in x. And then instead of my g of x value, I'm going to go ahead and substitute in x plus 3 because they equal. So I have x plus 3. And now I'm going to go ahead and combine those. And when I combine them, I can add like terms together. So I would have 1x plus 1x gives me 2x, and then plus 3. And that is what that function operation would look like. We're just using algebraic operations. The same thing goes here too, that if we use the same f of x, and I'm not giving you every example, but I'm giving you some. Right here, if we use multiplication, okay, if I have f times g of x, that's what that indicates there, not a big deal. Or it could also be the same thing as f of x times g of x. Well, if I do my substitution, I'm going to substitute these same things in. For f of x is going to be x, g of x is going to be x plus 3, and that is going to give me then x times x plus 3. I'm going to write it as this because we know parentheses is going to end up being that, being multiplication. So now when I combine these, I'm going to go ahead and continue my operations, and I'm going to distribute the x outside into everything inside, and that's going to end up giving me x times x, which is going to be x to the second power, and that falls under my laws of exponents. And when multiplying like bases, we add the exponents, and that is x to the first times x to the first, which gives me x to the second, plus 3 times x, which is going to give me 3x. And that is the answer to f times g of x is actually going to be x squared plus 3x. Now they asked me to also evaluate. And evaluate means that I'm going to plug in a value that they gave me into my function, and I'm going to get something out of it. And I'm going to go ahead and carry this to the next slide here, just as an example. And we have f g of x equaled x squared plus 3x. And they want you to evaluate it for 3. And what they're doing here is, if you notice, I have f times g of x is equal to x squared plus 3x. Well, f times g of not x but 3. So what they're telling me here, this is function notation. They're telling me that they want me to replace everywhere I have an x, replace it with 3. And that is going to be where we're going to go with this. So do my substitution. Instead of x, I'm going to have 3 squared plus 3 times x, which is now 3. And that is going to give me f of g of 3 is going to be 9, right? 3 squared equals 9, plus 3 times 3 is 9, which is going to be 18. And that is going to be f times g of 3 is equal to 18. So when I graph that, if you were looking at a graph, this would be f of x and f of g of x, and this would be x. Well, I know that when x was 3, I'd have to go all the way up here to fg of x is 18. So that would be 3, 18. If I'm trying to think and visualize it as a point. So remember, when I plug 3 into my function, and my function we said was this, my output was going to be 18. So my domain is my input. So when I have a domain of 3, my range is 18. There you go. So just some function notation reviews. Okay, so looking at this as an example for us to work through, what is the equivalent expression to g minus f of 3? Okay, so we didn't do this one before, but that is an algebraic, or that is a arithmetic operation, and it's subtraction, the difference, and we want to take g minus f. So if I have, I can rewrite this as g of x minus f of x, okay? And so when I do some substitution, I would say g of x, as we have right here, is going to be 6x, and f of x is going to be 4 minus x squared. So g of x is going to be 6x minus 4 minus x squared. You'll notice I put that in parentheses because we're going to have to use the distributive property here when we do that. So however you choose to do it, I'm going to multiply everything by a -1, and that becomes from subtraction to addition, from a positive 4 to a negative 4, and then from a negative x squared to a positive x squared. Okay, so now we have an expression where we can combine some stuff. There's nothing here to combine, so if I rewrite it in standard form, I have x squared right here, plus 6x right here, minus 4. And there you go, there's my new expression of g minus f of x equals that. And then it wants me to evaluate it here for the value of 3. So wherever I have an x, I'm going to input 3. So g minus f of 3 is going to be equal to 3 squared plus 6 times 3 minus 4. That's going to be 9 plus 18 minus 4, which is going to give me 27 minus 4, which is going to be 23. So g minus f of 3 is equal to 23. And this might be more than you really need, but it tells me that I should know that 3 is my input, the x value. 23 is my output, the y value. And let's see, one more. Okay, so here we're looking at, we have f of x is x squared minus 2x, and g of x is 6x plus 4, and it wants to know which values of x does f plus g of x equal 0. Well, if we do this thing first, let's go ahead and combine those two things. Okay, so I've done the combining. I have f of x plus g of x, and here we go. I have f of x plus g of x, and I end up getting x squared plus 4x plus 4. Okay, but it's asked me which values of x does this function, this combined function, equal 0? Well, I'm going to do some substitution right here. So I'm going to substitute in this for what value? For 0. And when I rewrite that, that is going to look something along the lines of x squared plus 4x plus 4 equals 0. And now, in order to solve that for 0, you are going to need to figure out, you got to factor that. Do something like that. And then we know that, well, x is going to be split up there because I have x squared and x squared. I'm sorry, x squared, so I would have x times x. I'm reversing the multiplication process. And then 4 here, I know, well, what are the products? When I factor 4, what are the factors of 4 that add up to be 4, which it turns out to be plus 2 plus 2. So now I've simplified that. I've factored it to where I have the same values of x. And when I solve for 0 using the 0 product property, and I would have x plus 2 equals 0 or x plus 2 equals 0. So yeah, I can just do it one time since it's the same answer, and then minus 2x equals negative 2. So here, when f plus g of negative 2, when I put negative 2 into my function, the output is going to be 0. So at what value of x does this equal 0? Negative 2. Function operations, a lot of things going on there. We may have to do some remediation when it comes to this factoring process. But it's one of those things that you should be able to recognize at this point in your mathematical careers.